Hello everyone, class 12 topic is reaction of alcohol as a whole molecule. In previous videos, we have covered those reactions in which there is a breakage of oxygen hydrogen bond. This is a general formula of alcohol, ROH. In first category, we have discussed those reactions in which there is a breakage of oxygen hydrogen bond. In second category of reactions, we have discussed those reactions in which there is a breakage of carbon oxygen bond. Now third category, this category in which whole alcohol molecule will be involved. Those reactions are: number 1, dehydration of alcohol; number 2, oxidation reactions of alcohol; and number 3, reaction with copper. These three reactions we will cover in this category. So today, dehydration of alcohol. The meaning of dehydration, as we all know, dehydration means loss of water molecule. Means in these reactions, alcohol is going to lose water. What are the conditions required? Alcohol need a catalyst for dehydration. That catalyst will be acid, like H2SO4 or H3PO4, phosphoric acid, these. And what temperature? Let me inform you, with temperature, products will be different. I am going to perform here the temperature that will be 433 Kelvin to 443 Kelvin, this range. In this range of temperature, after dehydration, it will produce alkene with the release of H2O. Again, note down the range of the temperature, because if you will change the temperature, products will also change. In this video, we will deal with this range. Alkenes will generate. You have to cram it. 433 Kelvin to 443 Kelvin, it will give you alkene on dehydration condition. Acids are required as a catalyst. Now let's understand how that reaction is happening. So for that, first I am going to write original reaction, like alcohol I have used ethanol, ethane, 1-ol, and I am going to react it with sulfuric acid, which is working as a catalyst here, and temperature, as I told you, 443 Kelvin temperature, around 443 Kelvin temperature. So let me tell you the trick how to do dehydration of that. As you know, water molecules, formula H2O. So what to do? OH and the neighboring carbon, this carbon, it's hydrogen. Neighboring carbon, the very next carbon to OH carbon. This is a bond between OH and this carbon. A very next carbon to it, it's H and it's OH. Just release out as a H2O. This is just a trick. And between these two carbons, bond will generate. This one. So alkene is generated, you know its name, ethene. Similarly, if you are performing dehydration of this one, so what to do? OH is connected to this carbon, next carbon to it, hydrogen of this carbon, and OH from this carbon, H2O will be released out, and between these two carbons, you have to generate a double bond. Alkene will be generated. So this is a trick we have to do dehydration of dehydration of alcohol at the temperature of 433 Kelvin to 443 Kelvin. Now let's check the mechanism part. How that reaction is happening. Mechanism very easy. It's a three-step mechanism. Three steps mechanism. Step number 1. Here we have a role of acids. Like sulfuric acid you have used, we know acids have a tendency to donate H positive ions. And these H positive ions are electrophiles. They are looking for electrons. Why they are electrophiles? Because they have a vacant orbital, shortage of electron they have. So they are looking for electrons. Who can provide electrons? Yes, alcohol is there, which will provide electrons to it. Like I have used ethanol, CH3, CH2, OH. And in alcohol, which atom? Oxygen atom, which have a pair of electrons. Now, there is an attack of that, due to which another molecule will generate between this oxygen lone pair and this hydrogen vacant orbital. Dative bond will generate like this. Plus one charge will be on the oxygen. Many a time we have discussed it, because out of two electron, one electron it will completely shift toward hydrogen for the bond formation like this, and one it will keep with itself because it is shifting one electron completely toward hydrogen. So that's why it is carrying plus one charge. This molecule we call protonated ethanol. Protonated ethanol. Why? Because this H positive ion is also known as proton. And it has attacked on ethanol, so that's why we are calling it protonated ethanol. Or you can call it oxonium salt, because oxygen is carrying plus one charge, so we are calling it oxonium salt. This is the first step. Next step, step 2. That protonated ethanol generated over here, CH3, CH2, this one, is it stable? No, it is highly unstable because oxygen is carrying plus one charge here. So what this oxygen will do? It will start breaking bond from carbon side because it's want stability. In this condition, it is highly unstable. Obviously, when a bond will break, both electrons will get completely shift toward oxygen because oxygen is more electronegative than carbon. Here we have a generation of this intermediate carbocation with the release of H2O. Ethyl carbocation, you can call it ethyl carbocation. Because this carbon has lost its electron completely toward oxygen, so around this carbon vacant orbital will generate this one with a plus one charge. So ethyl carbocation is an intermediate over there. This step is a slow step, second step. And we know slow steps are rate determining step. Means the speed of the reaction will be decided by this step, second step. And then finally, the third step, step third, this carbocation which is generated over here, this carbocation at this high temperature, 433 Kelvin to 443 Kelvin, what will happen at this high temperature? This neighboring carbon will help this carbon to get its stability back. It is highly unstable because vacant orbital plus one charge. Carbocation it is. Intermediates are highly unstable. So this neighboring carbon will help it. How? We know carbon electronegativity is more than hydrogen. So when it will break bond from hydrogen, both electrons will come closer toward carbon, and these electrons it will provide to its neighbor carbon for the bond formation. This is a vacant orbital, this is a pair of electron, they will combine here, vacant orbital will come here, pair of electron will come here, and between these two carbon a new bond will generate. Second bond, this one. What is this? Ethene, the final product. And here we will have a release out of H positive particle, this one. Now what this H positive particle will do? It's an electrophile. It will repeat every step again. Remember, in first step, H positive ions were generated by sulfuric acid. And those H positive ions are carrying out that reaction. Once sulfuric acid has provided H positive ion, after that H positive ions are continuously getting generated like this. And this H positive ion will repeat whole step with another molecule of ethanol. Means it will repeat the whole cycle. And continuously in third step again H positive ion will generate, and that H positive ion will again start the reaction from very first step. Again H positive will generate, again from very first step. So in this fashion, ethene molecules will be continuously generated. So this is the mechanism we have for dehydration of alcohol to produce alkene at the temperature of 433 Kelvin to 443 Kelvin. Now, I am leaving you with one question and try to solve it by yourself. What will be the reactivity order of 1 degree, 2 degree and 3 degree alcohol in dehydration reactions? Try it by yourself. If you can solve it, very good. Otherwise, we are going to solve it in a next video. Reactivity order of 1 degree, 2 degree, 3 degree alcohol in dehydration reactions. Thank you very much.